All right, day 3. Now we're going to be sketching polynomials in factored form. Okay. So we have x cubed minus 6x squared plus 9x standard form. What degree is it? Whoops. Okay, why is it not working? Try that again. 3. Okay, the degree is 3. The degree is the exponent. What is the lead coefficient? Positive 1. Now we're going to factor it. Okay, so we're going to do synthetic division. We have a 3, a 2, and a 1, right? And it stops. There is no 0. So our numbers are going to be 1, -6, and 9. The problem is, what number goes in the box? We don't know. Now, we could guess and check, but we're going to let you use a calculator to help you get a head start. So we're going to put this in calculator. Go to y equals, clear it out. We're going to put in x to the third power, down, minus 6x squared plus 9x. All right. Now, we can see what it looks like. It doesn't really matter. Okay, positive cubic. Now, here's what we're going to do. We're going to go to the table and look for x-intercepts, zeros. Here's 1 at 0, 0. And here's 1 at 3, 0. And if we look at the graph, that looks about right. 0, 0, 3, 0. So it looks like we have some possible intercepts, maybe all of them. But we need 1 to start with. So let's start with 3, 0. We could start with 0, it doesn't matter. We've never done 0 in the box, but actually let's do that just for the heck of it. It's new. We think 0 is a factor. So we drop the 1, multiply by 0, add straight down. Multiply by 0, add straight down. So that gives us x squared, we start with the 3, minus 6x plus 9. Now we factor this. Now remember, this is a factor of x minus 0, also known as just x. All right? And then what we're going to do is we're going to factor this. Well, x times x is x squared. We need two numbers that multiply to give us 9 that add up to 6. Well, that's 3 and 3. And they both have to be negative. Now remember, you got to bring this down and say this. Okay? And that's my answer. Now, let's say, just for the heck of it, let's say I did go with 3 in my box. Which remember, that represents x minus 3, 1, -6, 9. Drop the 1, multiply by 3. Add straight down, multiply by 3. There's my 0. Now what that would have given me is, this is a little weird. Remember, I start with 3, so this is x squared minus 3x. Well, the only way I can factor this is to factor out an x, GCF. Well, remember we said this was x minus 3? Same answer. X minus 3 times x minus 3. So no matter which one you start with, you're going to get the same answer. But let the calculator help you start. All right, factored form polynomials. So we have this right here. 3 times x minus 1 times x plus 5 times x minus 5 squared. Remember, this is really x minus 5, x minus 5. So how many x's are there? That's why I've reminded you of that. There's 1, 2, 3, 4. Or 1, 2, 3, 4. The lead coefficient is this number up front. What is it? It's 3. X-intercepts. How many will there be? Well, this one is 1. This one is -1. That's 2. And this one is 5. But there's 2 of them. So where will it cross the x-axis? At 1, -1, and 5. But it didn't actually cross. It's going to actually bounce. How many times does each x-intercept show up on the graph? Well, 1, like I said, shows up once. -1 shows up once, and +5 shows up twice. So that's the multiplicity, we call it. Now, if we put it in the graph, you'll see what I'm talking about. So y equals, clear it out, 3 parentheses x minus 1, x plus 1, and x minus 5. We could write it twice or just say squared. Now let's look at this. You see how it comes down, hits there, that's 1. Comes back up, hits here, that's 2. It passes through, it comes up off the chart, comes back down, and it actually bounces off the floor here. That's why we call it 2. It hits on the way down and on the way up. It's called a bounce. So multiplicity is the number of times each x-intercept shows up. If the multiplicity is even, it bounces. And if it's odd, it goes through. And each x-intercept has its own multiplicity. All right. Lots of stuff going on here. So what's the degree? Well, this is x to the 1. This is x to the 1. And this is really going to end up being x squared. So 1, 2, 3, 4. The lead coefficient is -2. That tells us it is going to be upside down and it's going to be an m. It's also going to be a little narrower because of the 2. Well, that is an even number. My x-intercepts, -4, 2, and 1. But remember, and I'm saying those each equal to 0, the 1 gets 2 of them. Actually, I don't even need to write it twice. We'll just say a multiplicity of 2. So -4 has a multiplicity of 1. 2 has a multiplicity of 1. And 1 has a multiplicity of 2. It's going to bounce. So I can put my dots here, here, and here. Now, without sketching it, graphing on the computer, don't do this, but you can tell it's going to do something like this, go up. It is going to bounce here, go back up, and come back down. Something like that. Now, we're not going to go with that horrible of a graph, obviously, so we're going to let the calculator help us. So, y equals, clear it out, -2, great negative key, 2, parentheses, x plus 4, x minus 2, x minus 1, and we're going to square that and graph it. Okay? Generally what I did, just, I didn't have the height of everything. Okay? So I go to the table, try to find some points I can use. Obviously, I can't use 0, 16. I can't use 3, -56. So I really only have my zeros. So I just need to generally sketch it. But I want to do it a little bit closer to what I saw here. Okay? So obviously, when I graph this, it's going to go off the chart here. It's going to come down and have a little bounce and then go down like this. In behavior, they're both going towards negative infinity. Okay. Sketch the graph. The degree, 1, 2, 3. So this is going to be a cubic. Lead coefficient is 2. Now my intercepts. When there's just an x by itself, there's no plus or minus, that's 0, that's 4, and that's negative 3. So 0, 4, negative 3. 0, 4, negative 3. Now, this is a positive cubic, so it's going to have that general shape like that, but let's use our calculator. So y equals, clear out what I have, 2x, parentheses, x minus 4, x plus 3. Graph. All right, so probably not going to be any points really we can graph here. Off the chart, off the chart, off the chart, right? So we're just going to kind of sketch that. All right, so it starts down here, going this way. It's going to come up through the 2, off the chart, hit the 0 here, off the chart, come back up through the 4. Do your best. That's good enough. Now, what's happening on in behavior? Well, as it's going left, this way, it's going down towards negative infinity. And as it's going right, it's going up. So right, up, positive infinity. Okay, now this one we're going to factor. Now remember, we talked about this in the previous day, the review. This is really no different than x squared minus 13x plus 36. Okay? So we need two numbers that multiply give us 36 that add to negative 13. Well, that's 9 and 4. Easy enough. And they're both going to be negative. So when we factor this, same thing, except it's going to be x squared. That's the only difference. Minus 9, minus 4. Now the beauty of this is these are both perfect difference of squares. So this factors to x plus 3, x minus 3. And this one factors to x plus 2, x minus 2. So what are all my zeros? Negative 3, 3, negative 2, and 2. Negative 3, 3, negative 2, and 2. Okay? And we can actually just put in our calculator the standard form, save us a bunch of keystrokes. So x to the power of 4, come down, minus 13x squared plus 36. And let's see if we have those same numbers. Negative 3, 2, negative 2, positive 2, positive 3. Same zeros. Notice again, nothing we're going to be able to graph. So let's see what it looks like. It's just a big old W. So, and I think, if I remember correctly, well, let's see. We do have these that we can maybe graph. Let's see the table. Let's see what negative 4 gives us. Nope, not going to really work. So we're just going to kind of do a W. Make it look kind of like what was on the graph, and that's good enough. So the degree is 4. Lead coefficient is 1. Okay, 4 is even. It was positive, so it was a W. And here's my numbers. Negative 3, 3, negative 2, and 2, and they each had a multiplicity of 1. In behavior, since it's a positive, they're both going in the same direction. Left up, right up. Right, here we go. Factor it first. So we're going to factor by grouping here. So only thing I can take out is x squared. That's going to be x plus 5. I cheat and put x plus 5 right here. Now what negative 25 divided by what will give me 1? Negative 25. Hook these up. X squared minus 25. And then x plus 5 we write once so far. But this one breaks down to x plus 5, x minus 5 because it's a perfect difference of squares. 25 is a perfect square. So now look, I have two x plus 5s. So negative 5, 5, and negative 5, which means I'm going to have a bounce. I have a multiplicity of 2. So this was a cubic. My Lie coefficient was 1. It's odd. It is positive, which means it's going to have this general shape. And I have -5 twice, 5 once. So -5, I'm going to have a bounce, and at 5, it's going to go through. So you can kind of get a general idea what it's going to look like. It's going to come up here and bounce, come down here and go through, something like that. Okay, let's go to our calculator and see specifically though. So we clear it out. We put x to the third power, come down, plus 5x squared minus 25x, whoops, minus 25x minus 125. Comes up, bounces off the chart, goes through. Hey, look at that. I pretty much nailed it. And in behavior, as it's going left, it's going down. So left, down towards negative infinity, and right, up, positive infinity. And that's it.